Everybody tells us to learn deep learning and artificial intelligence, but they don't tell how. So if you have been wanting to learn it or you have some bits and knowledge of these concepts, in this video, we will study all the essential fundamental building blocks of deep learning. So this is the absolute essential thing everybody needs to know. And if you build the knowledge on top of this in an incremental way, you will be able to consolidate all your deep learning knowledge. So start from here and build on top of this, and hopefully it should be very helpful. So for that, this is the course as an inspiration for it. It's a course available on Kaggle Learn. You can go here. It is a extremely simple 6 tutorials, and by end of which you would have learned and trained 2 to 3 neural networks. A very nice way to practice these things. We will take the same knowledge and cover all of these fundamentals one by one. Okay. So we'll start with this. What is a neural network and what is its most fundamental building block? A neural network is nothing but imagine multiple neurons which are connected to each other. What is it inspired by? It is inspired by our brain. Our brain, if you know what it looks like, if you slice our brain through electron microscope, you will see our brain is nothing but cells, fundamental cells of neurons connected to each other. That's it. So brain of you, Elon Musk, Einstein, Newton, Nikola Tesla, or anybody, it's nothing but few neurons connected to each other. If you somehow could replicate the structure of, let's say, Elon Musk, you would have Elon Musk's advice just at in whatever thing you require. So that is the power of our natural neural network. And if we can master the same power in this artificial neural network, where our brain's fundamental unit is neuron, a network is nothing but multiple such neurons connected to each other. This is the artificial neural network. And this is it. When we learn and reach the end of this video, we would have learned what is the neural network. Even the most complicated neural network like ChatGPT, it is nothing but a simple expansion of the neural network. The network is much bigger in size, but in the end, it is still a network. So fundamental building block of a neural network is neuron. So if you go to my GitHub profile, you will find this code in that notebook. Let me just open my profile. I will make it the first link here, where is introduction to this. So which one to remove? I will remove these. So you will find this repository, Introduction to Deep Learning Essentials, here. In this, the code is just neural network architectures, and this is how we are starting all the fundamentals everybody needs to know. Let's start with the programming language. Python is the most popular language everybody uses, and you have to know it because even in future, that is the language which is going to be of artificial intelligence. Okay, so you don't need to be master in Python programming. As long as you know beginner to intermediate level, and you know the libraries required for neural networks, you are fine. Okay, so starting from there, which libraries? There are two libraries, PyTorch and Keras. I'm using here Keras, and so does Keras tutorial. Let's see why. This is the first thing you just executed, and ensure that Keras which you use is the latest version. Check how you can do that, because the latest version is the in just one network you can write it as a PyTorch network or a TensorFlow network. So it's nice. It makes the jobs a lot easier. So let me Okay, so let's execute this. What is a single neuron and how does it look like? So this is a simple neural network of one neuron. It is made up of just this part, which is this one neuron. So this is one. Okay. Now if I add this here and I do this equal to 2, these are two neurons. So if I make it 3, these are 3 neurons. If I make it 4, they are 4 neurons. So this is the neural network increasing the number of neurons. How we write that in Keras? We use layers.dense. And we specify the number of neurons we have in that group. That's it. This group of those neurons at the same level is called as a layer. And that's why the code is written like this. If you want to know how to write this code, it is pretty simple. Keras is designed in such a way that all these layer names and everything required for neural network, it's designed for easy remembering and recall. So in Keras, everything is starts at head. And if you want to model which is just a sequence of models, this you just write it directly at top of Keras and you get it. And whatever is important in Keras, whatever you require, let's say you require layers, you say keras.layers. Let's say you require error functions, you say keras.losses. If you require matrix, then you say keras.matrix. You see, it's designed for easy recall, and that's why I like this library. So keras.layers.dense, and then this takes in a parameter called as units. I could write it like this. This is like a one layer with one neuron. But I like to write what this number represents. And you can find those details in documentation of this layer. So go to Keras documentation and over time, these are just 10 different kinds of layers. Over time, you will remember all their names. So check its documentation and find out what this number goes to. It goes to something called as units. So instead of neurons, it is units. And done. A single neuron of a neural network is written like this. A layer is a group of such neurons. And if I write 20 instead of 2, these are 20 neurons. Okay, let's move forward. Then what is a network? So network is just this layer is multiple neurons increased in this way. You can similarly do, add just one layer, another after this. So you keep adding multiple layers and you keep adding multiple such neurons in those layers. That is a deep neural network. Even ChatGPT is something like this. So if you go in the code is absolutely simple. Code is absolutely simple. It is, you write it like this. You say keras.sequential, and then I just wrote the way it is. Then for layers, I have simply imported it directly. So I could either import layers as this thing in the beginning itself, or I write keras.layers. Whatever. Okay. So this is one layer of a neural network. And after that, we have another layer. If we want 6, 7 layers, we can do them like this. So here we have 2 layers. After that, we have one final layer. Okay, so this is the neural network. This actually connects to one absolute important representation of a neural network, which is in neural network, in the beginning, you have a input layer. Okay, and then you have something what is called as hidden layers. And then you have something which is the final output layer. Okay, so this diagram like this. So always in all the diagrams, it's shown like this: input layer, hidden layer or layers, and output layer. Input layer, hidden layer or layers, output layer. Okay, so the same thing here I have written in the code also. There is a input layer. It simply defines what is the shape of the input I'm taking. So if I'm taking 8 values, it's going to say 8. If I'm taking at a time 64 values, it is going to say 64. So then I have this layer, I have dense and units as 4. It's first hidden layer, this is second hidden layer, and this is the final output layer. Units we already know. Okay. Then one thing which is after this, which we need to know is something which comes after, which is activation function. Okay. So neuron actually has one extremely interesting function, which is the way the name tells you what it is doing, activation. This defines conditions for activation of the neuron. Okay, so if certain conditions are met, the neuron is activated, otherwise it is deactivated. So for example, there is a tiger in front of you, jumps suddenly and you are afraid. So in your brain, there are going to be only two neurons which are deciding something, run or not run. So the right one needs to be activated, and that activation needs to have that knowledge as a part of it. So this activation is the how the layer takes the function which will be used for activation of the layer. So that the right thing is activated and wrong thing is deactivated. So in Keras, this is how you write in an extremely easy way. Activation function is part of the definition of the layer itself. If you want to write the same thing in PyTorch, it is a bit different. Okay. I will say import torch. I want to show you how the torch code is. Torch model is similar. It's torch.nn dot torch.sequential, but the difference is the sequential I know is present in torch.nn. Here in PyTorch library, everything related to neural network goes into NN. N stands for neural and the next N stands for network. Again, torch.nn, and then that's the layer. So here the layer name is different. It's called as linear. Okay. And it has formats like it defines what is the incoming features and it defines what is outcome going features. And that's it. In PyTorch, you can't write the activation function inside. You have to write it separately. So the separate thing is this. This is the separate activation function. So Keras, it's just one layer definition and everything is inside. Whereas in PyTorch, you have to write it like this. And you also have to say in features and out features. Whereas the incoming features are not included here in Keras definition. Okay. So if you check here, this units tells us there are 512 neurons. Here it tells us the dimensions of the output of the layer. It says it's 512. And as you can see, the number is same. It means the total number of neurons here is 512 only. And each neuron is giving one output. And because there are 512 neurons, there are 512 different output features. That's why we name it as out features. So we are talking from point of view of data, not neural network. And that's why it has been named that way. But when we read this code in our brain, we should know, oh, this is total number of neurons are these many. For each neuron, there are these many incoming connections. This is how we should read. Okay, so moving forward. Then once this definition and everything is there, we actually jump to the main part, which is what is a neural network and all. Okay, so let's go to that solution. And for that, I have a separate notebook, complete neural network pipeline. Okay, so let's go and cover this one by one. Every neural network, even ChatGPT and text to image generator, a company of $1 million revenue or a company of $1 trillion revenue, it is going to have a neural network which is going to have the same structure. They will have much more complex pipeline. The reading of data will be from a lot of complicated places, but it is always going to be reading the data. So we are understanding all the fundamental blocks of neural network. First, block number one, get the data from which we learn the patterns. And these are few important things which, not many people focus, but we need to know. More complex the patterns present in the data, more complex the model is required. So if you are solving a complicated problem, we need a even more complicated network. This is obvious if you think about it from common sense perspective. So for example, if you want to measure animals by their intelligence, we of course know that if the animal has a smaller brain, it is going to have a smaller intelligence and it is going to be able to solve smaller problems. We humans, more number of bigger the brain grows, more complicated survival systems, more complicated the navigation, and everything is more complicated. It's simple observation of nature. The same thing here. Okay, the reason it is fun is it can be rephrased in a different way. If we want to solve a complicated problem, all we need is a more complex model. This is the fun corollary of this part, wherein we can solve any problem as long as we have enough complex model. And that's amazing. Okay, so this is the code for it. Do not worry about the details here. Right now, I am simply downloading data in an extremely simple way. If you just get used to the PyTorch thing, you'll find it to be very easy. Code I have written to be very easy to read. All we need is we need the functions which load the data. That's it. And these are the codes which has been written. Very simple. Okay. This is the first part, learning, getting the data to learn patterns from. Then second part is defining how we train the model. We already know what is a neural network. Neural network is an architecture written like this. What happens when we create a model like this? I didn't show you, but it's a very fun thing. If I say model.summary, you will see that how many number of parameters are present in this neural network. Before it gave wrong answer because I don't think I had executed this. But you know there are 3 layers. Check. There are 4 layers here. In each layer, total number of parameters are this. And remember our corollary, more complicated the problem, more complicated network required. A complicated network has more number of parameters. So it's a very simple relationship between parameters and its intelligence. This is a good number. It has around 500,000 parameters, and in RAM, it takes just 2 MB. These are important numbers because eventually the required parameters are gonna grow to trillions. And that's where intelligence comes into picture. A trillion parameter model is gonna be very intensive memory wise. It is gonna be very intensive to load the data for it. It is gonna be very intensive to do training. So that's where we need to be even more intelligent. Okay. So whether it is a trillion parameter model or a simple 100 parameter model, training is also the same way. It's same for all of those smaller to bigger network. What is it like? You have to know that all neural network searching is the most brute force method we ever have. It is a gradient descent. What this algorithm is very simple. Let's say a output value is dependent on 100,000 parameters. Okay, so if it is dependent on 100,000 parameters, somehow I correct each parameter just by a tiny bit in the direction of the right direction. Eventually, I will reach the right answer. This is the brute force method. We do, you know what? I don't know the right answer, but I'm just gonna make every single one person to go in the right direction bit by bit. Because if you take small corrections, you don't go wrong too much. So that's the logic of this brute force algorithm. The thing is, because it is so brute force, it takes a lot of time. The network we wrote here, let's write the network. Whatever network we write, the training part takes a lot of time. How? Let's check the training code. For training, I have used a library called as PyTorch Lightning. It's a library which makes writing the training part and ensuring that, if the model is huge, you will need GPU. Because even if you have 100,000 parameters and you run it on CPU, it will take 15 minutes minimum. It's so slow. CPUs are very slow. You can't play a video game on CPU. It's gonna be very slow in FPS because it's not optimized for parallel processing. So even for this model, we need parallel processing and managing that where the data and model should go. Lightning takes care of it for us. That's why I'm using PyTorch Lightning here. Okay. So when we use the right tool for the right thing, we save a lot of our work. We don't reinvent the wheel. This is something I learned while learning video games. So I'm learning video game development because it's an application of AI. And in that, there were these few things I was trying. For example, the scene I'm building is Ganga. River Ganga is walking on a river bed, and that's a part of a Mahabharat scene I'm trying to build. And I was learning Unreal Engine for it. You see, if I had spent a lot of time building everything from scratch, it would have taken me a lot of time. But I spent money on few things which make essential things easy. So this is for Fluid. It's $350. I spent the money on it so that I don't have to spend my time on learning something so complex. So this is the demo of that. The audio is also working. See, the audio is also working. It's lagging a bit, but you can at least see the whole water and everything is working fine. Correct? So by buying the tool, I saved a lot of time and I was able to do this a lot faster. Same for reasoning for this using Lightning. I said, how is model training? It doesn't matter if model is one parameter or a trillion parameter. We use the model to do some prediction. And each and every parameter of the model is optimized in the right direction. That's what I said, brute force. If I have trillion parameters, this loop is going to be executed trillion times just for a single example. We take a single example and we find its prediction. And then we find out the error of that prediction and we simply try to minimize each parameter in the direction of this, reducing this error. So when we reach error 0, we automatically reach the right answer. That's the reverse logic we are using. By reaching a model whose error is 0, it means its accuracy is 100%. So finding the parameters where error is minimized, the job of that is done by optimizer. And PyTorch library has already implemented it for us. So we use it. Okay, so training, what happens? We kind of like do predictions, then we calculate error, and then we update parameters. So these are the standard 4 or 5 things you will see everywhere. I have written them the same way, but just organize them for easy understanding. Everything is explicit here. And when you execute this code, you will understand everything. So, this thing will make your learning job a lot easier. So this is for training, and then we have something is for validation. So in training, what we do is we learn from the data given. That's the training thing. But when we want to test how good our learning is, that's the validation. So it's like the final exam which we give, right? So in that's where invigilator we give the exam paper, we write, and then it gets checked. It's to check what's your true understanding, and it checks not only ours but everybody else's. So this is the same validation here. Okay, and then simply everything we need at the end of validation, and these are the things. Okay, so this is the code, and then finally is the architecture, the third part of the neural network. Architecture with more parameters can learn complex patterns. Everything is same. These are all the essential things of neural network. There is a term for it, which is important term to know, which is called as capacity. Network with high capacity has higher number of parameters. The higher number of parameter means it can learn more complicated patterns, means it can learn solve more complicated problems, and that's how we kind of like be valuable. So when we solve the most complicated problem, we are always going to be working on most bigger network, and there are going to be a lot of problems in that, and it's our job as data scientists to solve them. Okay, so here there are a few things which you will find very interesting. These are things like this. In brain of a mouse, there are 1 trillion parameters. Okay, currently ChatGPT is 175 billion. So even the current model is no, it's even if we reach 1 trillion, it's going to be only as big as a mouse. And you can imagine if mouse solves whatever problem mouse solves, they're not going to be probably everything we need, right? We definitely have more complicated problems. So for that, we probably will need bigger network. So for that, these are the terms. When the model is more complex than the data pattern, there is something called as overfitting. Data is simple and you have applied a unnecessary complicated problem. That's not right. And when model is simpler than the data complexity, that's underfitting. Okay. So these three things: data, how to train the model, and model definition. So this I showed in the previous thing, wherein we use Keras because it has the same code for Keras and PyTorch. Right now, PyTorch is the most popular library. That's why most of the codes you will find on Google will be of PyTorch. But code of Keras is easier to read. So that's why I wrote this Keras code so that we understand what is present where. And PyTorch is the most popular one. That's why we need to know that. Okay. So I wrote a model of this input, and there is just one layer here, and then there is the final output layer. So when I execute this, when I get the data, train the model, trying to minimize the error, I will get an answer. Okay, so let me just show you this. So I told you the first 4 blocks: data, training the model, and then model architecture, and finally just prediction, right? So what is data given to the model? The most common one is images. Let's understand how images are. So whenever we see any image, it is actually simply a value of whatever color is present at that point. Our camera is 10 megapixel. It means it has 10 into 10 raised to 16 pixels. Mega is 10 raised to 6, right? So 10 megapixels is 10 raised to 6 pixels in width and height. So if I have a phone of just 1 megapixel, it is going to be 10 raised to 6 pixels. If I have a phone of 0.0001 pixels, then it is going to be 10 raised to 3 pixels. Okay. So here we have a number. More darker the value of the thing, higher the number value. This is how the image data is saved. Okay. We use maximum value as 256 because our eyes can only distinguish 256 shades of base color. So for between white to black, we can only see 256 shades. That's why we only save those many. So 256 is going to be black and 0 is going to be white. And this is how any image is. It is simply list of numerical values. Okay. This data goes to the model. And to the model, we need to specify what is the input. That's why we talked about data. So here for this, it is 28 by 28 pixels. The data we are using is very small. And the reason we are using very small is if we take a bigger data, it is going to take a lot more time and we are not going to be able to learn. So let's solve a simple problem, learn a complicated concept, and then we can simply scale the problem later after we have learned. So 28 by 28 pixel, So each neuron is going to have 28 into 28, and the parameters, which is nothing but the total number of parameters for each neuron, it has every value corresponding to every incoming. So if I have a neuron and we have 28 pixels coming in, there is going to be a value for every incoming pixel. As simple as that. That's the weight thing. That's the parameter. So when we have a bigger model, the incoming values, incoming parameters are bigger. So for this permutation and combination, if we have, let's say, 16 neurons, 16, 3 hidden layers and 1 output layer, these each connection is a value, and that value is what is the weight parameter. Okay. So when I talked about our brain and total number of connections in our brain, that is called as synapse. In neural network, it is called as parameter. And by connecting these things, I think it should become a lot clearer in your brain. What is a neural network in computer, in physical things? In our brain, it corresponds to the connection, which is called as a synapse. If the connection is strong, the value in that synapse is going to be higher. If the connection is weak, the value is going to be lower. And this is what we have here. So if we do, let's say, large number of incoming neurons, there are going to be more values of weight. Some weight will be very high. Those weights will be thicker. So you see, there are a few thick lines, few thin lines, random values of the parameters. Okay, so we have data. For each incoming data pixel, we have the parameter at each neuron, and we have multiple such neurons. They are all doing the same thing. All neurons have the same number of weights, but different. They have their own. Everybody has their own. And that's why neural network size increases. More the size increases, more complicated problem it can solve. That's what we have been iterating. Okay. What happens in training? Each and every parameter is changed into a direction where error reduces. That's it. If you have million parameters, we do million times. If you have trillion parameters, we do it trillion times. So this is when we take one data and update all trillion parameters to reduce the error. And then we take the next data, and then we take the next data. So this is what we keep doing. So if there is a model which is of 10 trillion parameters, then there is going to be 10 trillion error values for each parameter. And we can't visualize that. But we can visualize a 3D thing or a 2D thing. That's why in this gradient descent, we were visualizing a single parameter. Here we are visualizing just two parameters in X and Y direction, and in Z direction is the error we are trying to minimize. So in 2D, we need to go to this minima, and in 3D, we need to go to this minima. Different networks have these different curves. And whenever we learn, we find the value where the lowest permutation combination, where the lowest thing is present. So if you check here at this bottom point of this neural network, error is minimum, accuracy is highest. And we will reach that level when we do parameter optimization. Okay. And that is the code of which is written here in this Visual Studio training step. So when you spend more time, you will understand this thing in more detail, all the internals. You need to know all the internals, but first we need to know everything as a big picture, right? And we are learning that. We are learning all the building blocks of neural network so that on top of this, you can build your knowledge. So such a simple code, when you read and write, you will be able to write your own version very quickly. Okay. And then if you execute the line which I have written afterwards, after the training is done, this is how you train. It's via, I'm using lightning because it simplifies the training part. Okay. I'm using this TensorBoard library. It visualizes the neural network very easily, how it trained. And this is how it trained. Okay. Each and every single step you take, let's see, save as an image. Can I save it as image? No. But for each and every single thing on x-axis is a simple data point for which we have optimized parameters. Okay, so you see here, we have taken 1,800, no, 18,749 steps. And what are the number of parameters here? The total number of parameters, let's check. Model.summary. So 400,000 parameters have been updated 18,749 times to reach and values of those parameters where error prediction quality is what is the final prediction accuracy we reach. This is the validation accuracy. So the final accuracy we reach here is this final point 0.9799, means in percentage it is 97.99% accuracy. So for predicting digits, we were able to get this accuracy. So instead of that, we want to solve a real problem, a true real life problem in which we need to solve a complicated thing. So for example, here, this is the complicated problem where we have X-ray, and from that X-ray we need to actually study what is the progress of this degenerative spine disease, how good or bad it is. So this is also image. This is a huge image. So even for that, we just need to write the same network in the same structure. It's just going to be a bit different. It's going to be bigger. We need to change the architecture accordingly. But in the end, it's going to have the same 4 blocks. Okay. And going to the fundamental is when we have a bigger network, it means we have bigger parameter. It can solve a more complicated problem. So one way of increasing accuracy is simply increasing the network size. That is what people do. That is what people have done. Even in ChatGPT and everywhere else, people simply keep increasing the model size. They get higher accuracy. Now, how to do that increase in a more intelligent way? That's where the knowledge of deep learning comes into picture. But that is advanced knowledge. The absolute fundamental is just this. Okay. Currently, the neural networks we have are so inefficient that it's not even funny how inefficient they are. If we focus on optimizing, we can optimize it probably 10,000 times, or at least 10-20 times than how it is before. But current brute force solutions are not optimized ones. So there is a lot of research happening in how to solve them better. That's advanced knowledge. But master this fundamental and build the advanced knowledge on top of this. Now you are in an amazing place in your knowledge. So for example, this is all the deep learning research papers present here. Okay. So if you see, it is list of all the essential breakthroughs in each concept. So this talks about understanding the network better. We know what is network, we know what is training, we know everything. So from that fundamental building block, I immediately know where this knowledge is relevant. This is about optimization. So I immediately know it is in training. This is about different kinds of models. So I know the model architecture is going to be different. Here also it is about model architecture. This is about a different problem. So you see, by knowing the fundamental building blocks, you can connect all the latest knowledge to the fundamental building block and simply learn that extra delta. And that is how you learn deep learning. So this is the absolute fundamental building blocks for everybody must know, and everything is built on top of this. Master this and you have mastered the starting point into the field.